っくりレ夢ムです。
ゆっくりマリサだぜ。
Hi, Raimu Marissa. Hey guys. Are we living inside a simulation?
ゆっくりしていってね。
Section 1. Hook. What if none of this is real? Not in a philosophical, hand-wavy way. Not as a metaphor. What if the chair you're sitting in, the room around you, the planet beneath your feet, the stars above your head? What if all of it is data? Code running inside a computer so vast and so advanced that we can't tell the difference between it and reality? That sounds like a science fiction premise. Here's what's strange. It's also a serious scientific hypothesis. One that has been discussed in peer-reviewed journals. One that has been debated by physicists at major research universities. One that Elon Musk has publicly said he believes is almost certainly true. One that Neil deGrasse Tyson put the odds at better than 50-50. And one that, the more carefully you examine it, becomes harder to dismiss than you'd expect. In 2003, a philosopher at Oxford named Nick Bostrom published a paper so quietly unsettling that it has not stopped reverberating through science and philosophy for over 20 years. His argument didn't claim to know whether we're in a simulation. It claimed to prove that at least one of three things must be true. And two of the three options are terrifying. What is the simulation hypothesis? What's the evidence for it? And what does it mean if it's true? Billions of humans trapped inside a computer simulation, living their lives with no idea that their entire world was code. Most people watched that movie and thought, compelling premise, obviously fiction. And then, for years later, Nick Bostrom sat down and published a paper that made the premise considerably less obviously fictional. Bostrom is a philosopher, not a fringe thinker. He holds a position at Oxford University, one of the most respected academic institutions on Earth, and his work is taken seriously by serious people. His 2003 paper, titled, "Are You Living in a Computer Simulation?" was not a wild speculation. It was a structured logical argument, a trilemma, three possibilities, at least one of which must be true. And understanding the trilemma is the key to understanding why this mystery is stranger than it first appears. Section 3. The evidence. Let's walk through this step by step. Because the simulation hypothesis isn't just a thought experiment. There's evidence from physics, from mathematics, from computer science that makes it more than a philosophical curiosity. Exhibit 1. Bostrom's trilemma. Bostrom's argument starts with a simple observation. If technological civilization continues to advance, at some point it will almost certainly develop the ability to run detailed simulations of conscious minds. We already run simulations of weather systems, economies, evolutionary processes. As computing power grows exponentially, the complexity of possible simulations grows with it. Given enough time, a sufficiently advanced civilization could, in principle, simulate an entire world, including the minds living inside it, in enough detail that those minds would experience their simulated world as completely real. Now, if that's possible, then one of three things must be true. Option 1. Almost all civilizations destroy themselves before they reach the level of technological sophistication needed to run such simulations. They hit a wall, war, environmental collapse, some other catastrophe, and never develop the capability. Option 2. Civilizations that reach that level simply choose not to run such simulations. Maybe for ethical reasons. Maybe for resource reasons. Maybe it's just not interesting to them. But for some reason, almost no advanced civilization ever actually does it. Option 3. We are almost certainly living in a simulation right now. The logic behind option 3 is about numbers. If even one advanced civilization in the history of the universe has run detailed simulations of conscious minds, and if they ran many of them, as we might expect from a civilization with essentially unlimited computing power, then the number of simulated minds would vastly outnumber the number of real minds, by potentially billions to one. And if simulated minds vastly outnumber real minds, then the odds that you are a real mind, rather than a simulated one, are astronomically small. One of these three options must be true. Pick your poison. Here's what makes this argument so hard to shake. It's not claiming that simulations are definitely possible. It's not claiming that any civilization has definitely built one. It's saying, if it's possible at all, and if it happens even once at scale, then the math alone says we're probably inside one. You can't escape it by saying, but simulations aren't real. That's exactly what someone inside a simulation would say. Their simulation is real to them. Completely, indistinguishably real. The argument doesn't rely on the simulation being detectable. It relies on pure probability. Exhibit 2. The universe behaves like code. Now here's where physicists enter the conversation. Because Bostrom's philosophical argument gets unexpected support from a completely different direction. The universe, at its most fundamental level, behaves in ways that are strikingly computational. Quantum mechanics, our best current description of physical reality at the smallest scales, reveals a universe that is, in a very specific technical sense, digital rather than continuous. Energy doesn't flow smoothly in nature. It comes in discrete packets called quanta. Like pixels, like bits. There appears to be a smallest possible unit of length, called the Planck length, below which space itself loses meaning. Like the resolution limit of a screen, there appears to be a maximum speed, the speed of light, that cannot be exceeded. Like a processing speed limit. And perhaps strangest of all, in quantum mechanics, particles don't have definite properties until they are observed. They exist in a superposition of possible states, and only choose a definite state when measured. That is not how you'd expect a physical universe to behave. That is how you'd expect a computationally efficient simulation to behave, only rendering definite values when they're actually needed. Physicist John Wheeler spent the last decades of his career arguing that information is more fundamental than matter. His phrase was, "it from bit." The universe is not made of stuff. It's made of data. He was one of the most respected physicists of the 20th century. Exhibit 3. The mathematical precision problem. There's another piece of evidence that physics researchers find deeply strange. The universe is described by mathematics with a precision that has no obvious explanation. Not approximately described, not roughly described. Described with an exactness that allows physicists to predict the behavior of electrons to more than 10 decimal places. To calculate the orbit of planets centuries in advance. To describe the behavior of black holes using equations written on Earth. The physicist Eugene Wigner called this the unreasonable effectiveness of mathematics. It is unreasonable because there's no obvious reason a physical universe should be perfectly and completely describable by abstract mathematics. Unless the universe is mathematics. Unless the universe is information. Unless the rules of the universe are, in the most literal sense, code. That doesn't prove we're in a simulation. But it means the universe has properties that we'd expect from a simulation, and that we don't fully understand from a non-simulation perspective. Exhibit 4. Could we find the seams? The most exciting and most frustrating part of this investigation is the question of detectability. If we're in a simulation, could we find evidence of it? Could we find the equivalent of a glitch, an anomaly that reveals the underlying code? In 2012, a team of physicists at the University of Washington, led by Martin Savage, proposed a specific test. They argued that if the universe is a simulation running on a three-dimensional grid, like a cosmic version of the grids used in physics simulations today, then there should be a characteristic signature in the behavior of very high-energy cosmic rays. High-energy cosmic rays travel across the universe in ways that, in a grid-based simulation, should show slight directional biases. They should be subtly more likely to arrive from certain directions than others, reflecting the underlying structure of the grid. The experiment hasn't definitively resolved the question. But the fact that we can even propose a testable prediction, that the simulation hypothesis generates evidence we could in principle look for, moves it from pure philosophy into the territory of science. That's significant. Here's something real that researchers have noted. In 2023, scientists analyzing data from ultra-high-energy cosmic rays detected something that didn't fit existing models. Particles arriving with energies that, according to current physics, shouldn't be possible over the distances they traveled. It's probably a gap in our understanding of physics. It almost certainly has a conventional explanation that we haven't found yet. But the fact that our best description of physical reality has anomalies, places where the data doesn't fit the model, is, at minimum, consistent with a universe that has limits we haven't fully mapped. Whether those limits are bugs, features, or neither, that's the question nobody can currently answer. Section 4. The theories. The simulation hypothesis has generated serious competing responses. Let's walk through the main ones. Theory 1. The hypothesis is unfalsifiable, therefore not science. The strongest objection from many physicists is procedural. Science requires testable predictions. A hypothesis that, by its nature, cannot be distinguished from reality by any test is not science. It's metaphysics. If a simulation is indistinguishable from non-simulation. Theory 2. The computing requirements make it impossible. A different objection comes from computer scientists and physicists who argue that simulating a universe in enough detail to fool conscious minds would require more computing resources than the observable universe contains. Simulating every particle interaction of every atom in a single human brain for a single second requires calculations that would overwhelm any conceivable computer. Simulating 8 billion brains in a planet, plus every star and galaxy and quantum interaction across the cosmos, is so far beyond any realistic technology that it becomes effectively impossible. The strength. The numbers are genuinely staggering. The weakness. This assumes the simulation must be full resolution everywhere. A computationally efficient simulation might only render detail when and where it's needed, exactly what quantum mechanics suggests. Theory 3. We're in a simulation, and it matters ethically. Some philosophers take the hypothesis seriously and push it further. If there's a meaningful probability that we're in a simulation, who is running it? Why? And what are our obligations toward the simulator, or towards simulated beings we might one day create? Nick Bostrom himself has argued that if simulations are possible and common, we have strong ethical reasons not to create them, because creating a simulation of conscious minds that suffer may be a profound moral harm. The strength takes the hypothesis seriously rather than dismissing it. The weakness assumes simulated minds are morally equivalent to real ones, itself a contested claim. Theory 4. The simulation is real. Reality is defined by experience, not substrate. The most radical response from some physicists and philosophers is this. The question, is the universe a simulation, may be meaningless. If the simulation is running at the correct resolution, with the correct physics, producing the correct experiences, then it is reality. Reality is not defined by what it's made of. Reality is defined by what it does, by the experiences it produces. Under this view, even if we could prove we were in a simulation, it wouldn't change anything fundamental about the nature of our existence. We would still be real. Our experiences would still be real. Our connections to each other would still be real. The simulation would just be the name for the medium our reality runs on. Like asking whether a song is less real because it's stored on vinyl versus digital streaming. Section 5. The most likely answer. Here's where I have to be honest with you. There is no consensus answer. The simulation hypothesis is not proven. It is not disproven. It sits in a genuinely uncertain middle space that science has not yet resolved. What we can say is this. Bostrom's trilemma is logically valid. One of his 3 options must be true. The hypothesis is not entirely unfalsifiable. And the people taking it seriously, Bostrom, Tyson, Musk, Max Tegmark, physicists at major research institutions, are not cranks. They are people who have thought carefully about the question and found the probability non-negligible. What I find most intellectually honest is this. The simulation hypothesis forces us to confront how much we actually understand about the nature of reality. And the answer, underneath all our physics and mathematics and philosophy, is less than we think. We don't know what consciousness is. We don't know why mathematics describes reality so precisely. We don't know what happens at the Planck scale. We don't know whether the universe has an edge or what was before the Big Bang. In that space of genuine unknowing, the simulation hypothesis doesn't seem absurd. It seems like one of several possibilities we can't rule out. And that, honestly, is the strangest thing about it. Section 6. Conclusion. Here's what I keep thinking about. If we're in a simulation, who built it? And why? Maybe it's a scientific simulation. A civilization trying to understand its own origins by recreating the conditions of an earlier universe. Maybe it's something like a game, or an art project, or a historical archive. Maybe the beings running it are watching. Maybe they've intervened. Maybe what various cultures across history have called gods, miracles, answered prayers, maybe those were In the most literal sense, the programmer's making adjustments. Or maybe the simulation is running unattended. No one at the console, no one watching the output. Just code, executing, in the dark. There's a detail from Bostrom's original paper that I haven't been able to stop thinking about. Would the beauty of a sunset, or the weight of a loss, or the feeling of being exactly where you're supposed to be, would any of that change? Or would it turn out that reality was never about the substrate it ran on? That what makes something real is not what it's made of, but what it means that you think we're living in a simulation. What would change for you if you found out we were? Tell us below. Asterisk, subscribe for more investigations into the deepest questions hiding inside everyday reality.